right, next on the agenda is our compressor. So we have our windings here. Common, start, run. The common, start, and run go into the windings inside the motor. What is it that prevents the electrons from just taking where those wires are all coiled up together? What prevents those electrons just from simply going da-da-da-da?
Factory smoke.
The varnish, the insulation on it. The varnish is an insulation that makes those wires, the electrons, go in a circle. So what also prevents these electrons from that wire from going straight to the metal casing that holds it?
Factory smoke. Same insulation.
Same insulation, the varnish. The varnish prevents that. It prevents that from shorting out. It prevents it from shorting to ground. So you can have a compressor that shorts to itself, takes a short circuit, or it can also short to ground, which we call a grounded compressor. So if these electrons short to ground where the casing is, it's taking a shortcut home. A symbol for ground is usually something like that. So if electrons go from here to ground without going back through the other leg, that's a bad thing, right? Typically when that happens, you'll have a breaker that will trip immediately. Like it won't even, you reset it and turn it on, it immediately trips. Or you leave the AC calling where the contact was closed, and you go and try to engage that high voltage, the breaker, it just immediately pops right back, like immediately. That's a grounded compressor. It's 99.9% of the time a grounded compressor. Sometimes it's also a grounded, it can be a grounded fan motor or a grounded, I'm thinking of a word. You guys are throwing words out, trying to pull the word out, crankcase heater, or a shorted wire going into it where the wire is rubbing. But usually it means inside. So what's happening is the insulation on the windings is gone or damaged, and it's allowed a path to go to the metal frame. Is that a good thing? No. So if you see a compressor that's immediately tripping the breaker, you know it's going to be grounded, but you still want to check it. Check it with your meter. Check start to the metal, the copper. Check common to the copper and R to the copper. Now you don't just want to check to the metal on the motor. Why is that? Well, because of the paint on the motor. Paint won't give you a good signal, but if you're touching the copper of the pipe that goes to that motor and that compressor, you know you're going to get a good signal on it, good reading on that. Does that make sense? Now in every unit we work with, we're going to have a line 1 and a line 2 power supply coming in. Doesn't matter which one's which color. There's going to be usually one red one, one black one. Line 1, line 2. There's also a third wire. What's that third wire? What's the color of that third wire? Did you guys notice?
Green.
It's a green. And that went to just this one screw that's mounted to the casing. And if you look somewhere around that screw, you're going to see a symbol like that. What symbol does that mean?
Ground.
Earth ground. This is a safety device to save your life. To save your life. Save your life and everybody's life that's working on it. So that if this unit does lose its insulation and shorts to ground, the whole entire casing can become energized. By having this wire with the green wire connected there, it should all the way go back to the breaker panel. The breaker panel will have an actual grounding rod going into the earth of the ground. So that if this shorts, electrons will flow from here to the metal casing, for the metal casing straight to ground, and an unrestricted flow which should blow a fuse or trip the circuit breaker. The idea is once it trips the circuit breaker, it kills our source voltage, so there's no power coming to the unit. Does that make sense? Option 2, somebody doesn't hook this wire up. It shorts to ground. The casing of the unit is energized. There's no flow of electrons, so does the breaker trip? No. Breaker stays on. So you walk over to the unit, I'm going to work on this unit. And I'm going to touch the unit, and now there's a path to ground. The electrons are going to flow unrestricted through your body. Is that going to be a problem?
Yes.
Yeah, kind of going to be a problem. You can't collect that last paycheck. You're dead. It's going to be a problem. So that, what you call earth to ground or safety ground, that green wire, is to save your life.
If somebody doesn't connect that, she should just always turn off the power just in case.
No, if somebody does not connect that, we need to make sure that it gets connected. Two things. We have a disconnect box, which is what's mounted on those boards. And we have load, which is going out to our contactor. We have line that's coming into that. We are responsible as HVAC technicians up to that box. Okay? So we have to make sure the ground wire on that unit is connected to the ground wire in the box. Now when we look in this box, we're going to see where that ground wire comes in, and there should be another one that continues on. I've seen really good HVAC guys before replace a unit, replace the whip, and put a ground wire from the unit to this disconnect box. But from the box, there wasn't one going back to the breaker panel, and they left it. This shocked me one time. I went to the unit, had a grounded compressor. I didn't know it was a grounded compressor. It wasn't working. So I kneeled down to work on the unit. As I kneeled, the sprinkler was just running that day too. So I touched that unit, and I got a heck of a zap. What the heck? So I opened up the disconnect box to shut it off, looked at there. There's a nice, clean, new green wire from this disconnect box to the metal of the unit. But there was nothing from the disconnect box to the main panel or to the electrical ground, so there's no place. Even if I had just touched that disconnect box, would have shocked me. Thinking this had one of those rubber handle things on it, but they did only half their job. They didn't do it from here on.
That was an electrician.
And two things. One is we don't do that wire. Anything beyond that box has to be the electrician. But the job of the HVAC guy is to not have that unit running until the electrician comes and does that wire. You can't just hook the green wire there because it's like not even doing it at all. You have to make sure it goes all the way to ground. And if we do not call an electrician to do his job, then it's going to be a huge problem. Does that make sense? Now this box itself, legally, we're not supposed to change these boxes. Now in reality, you're going to see that most HVAC guys and your boss will require you to change out these boxes when they go bad, which is simple to do. You find the main breaker, you shut it off, check line 1, line 2, 0 volts, line 1 to ground, 0 volts, line 2 to ground, 0 volts. You unhook the wires from your line, you unhook wires from your load, take it off, put the new one on, knock out the little punch out, screw the pieces on, put the wires in, make sure the wire's in good shape, make sure they're good and tight, and you're good to go. But you have to make sure that it has the green ground wire on this side and on this side going to that equipment, because somebody can get hurt. There's been a lot of people electrocuted, like died from that. They didn't actually hook that ground wire up, and it could have been me. Came very close. Does that make sense? It's extremely, extremely important. On all plugs, even the plugs you plug in, most every plug will have 3 prongs, and some of your old outlets only have 2 prongs. So they'll take the starter and break it off so the 3-prong will fit the 2-prong. Never break that third one off, because you're losing your safety, especially with the metal drills, all the other tools we have that have metal cases. They need that 3rd prong. That 3rd prong is the safety. The electricity is going to go to ground, but it's going to go through you instead of through that green wire. It's a bad thing. Never break off a 3rd prong. You'll see that if you get to some of these big job sites, they'll check your extension cords, and if that 3rd prong is broken off, what they'll do is they'll unplug it, check with the non-contact voltmeter and make sure there's no power through it, and they'll take and cut that cord in short pieces. So now you have to replace the whole entire cord.
I've seen that. I've seen that. I was a roofer. I've seen that happen.
Yeah.
I was working on the SLS, and this electrician had one of those cords, and the prong was...
It was an electrician?
Yeah.
Oh, man.
And then you see the safety guy come up, he checked it, and then... I was like, damn.
Yep. You take care of your tools. And the reason they're doing that? To save lives. Hey, they're going to cut this cord up to let you know, wow, that's a big deal. He's going to cut up my entire cord because I broke this little prong off. Don't break the prong off, because he's saving somebody's life. Because what will happen is somebody's using a tool, shorts out, electrocutes somebody. Or they're rolling something across and it rolls through and cuts to the cord. And if it cuts to the cord, it'll hit from one line to ground and trip the breaker. But if it cuts to the cord and that ground wire is not hooked up, it energizes whoever's holding whatever's cutting through it, and it'll electrocute them. Does this make sense? It's a really big deal. Now, we had to go there to understand what we're going to talk about now. What we're going to talk about now is megging a compressor. So what we do is we're checking each terminal. We're going to check, just like we used the meter, we checked from here to ground, being the copper of the unit. What ohms should we have?
To ground.
To ground.
Some number.
Really? So you want some number of ohms flowing from the run winding to ground all the time? What do you want? 0? Unrestricted flow of electrons to ground?
No.
What do you want?
0. Open line.
0 flow, 0 resistance from electrons to ground, infinite flow of massive unrestricted flow of electrons. What do you want? OL, that's what I'm talking about. I want infinite resistance. I want it to be impossible for electrons to flow to ground. So from the run winding to ground, I want OL, infinite resistance. What about from the start winding to ground? OL, I want infinite resistance. What about from the common wire to ground? Infinite resistance. Now, if resistance drops and I have a path, I want it to go through this ground and ground out, so it trips the breaker. But I don't want a path from run to metal casing. I do not want a path from common to the metal casing, and I do not want a path from start to the metal casing. I don't want it. Does that make sense? So, we don't want it. So we check our ohm meter, and we want it to say OL. But our ohm meter has that little battery in it. It's not all that powerful. They make another tool. It's a little bit more powerful. Now, if there's a path, that's a bad thing. But the insulation in this winding can get damaged, and your ohm meter won't pick that up. But they make a tool called a megometer. We just simply call it a megger. And what we do is we hook one wire on the run winding, the other wire on the copper ground, and I press this button, and what happens is it has a little transformer in here, and it sets out the very high amount of voltage, and it checks mega ohms. So there's ohms, and then there's mega ohms. And it's checking to see what the insulation of the winding is like, and making sure that there's no path from that to ground. Because over time, the insulation of the winding starts to wear off. So I can check what the windings look like inside that compressor without actually opening it up. And I check between run and ground, between common and ground, and between start and ground. And make sure all of these, and it's real simple, you don't have to memorize all these numbers. I want it to be above 100 megohms. From here to 100 all the way to 1,000 and above, no light. It's good. I figure between, say, 30 and 100, caution. That means, hey, this insulation's breaking down in the windings, and we're starting to get a path. And over here, if I get less than 30, it's bad. Now, I've seen units that were running at less than 30. They were still running, but the insulation's bad on them. It's a ticking time bomb. It's a matter of time before these go out. I've seen technicians before go and check a unit, and they check the amps are good, they check the volts, and the volts are good, they check superheat's good, subcooling's good, they check the compressor amps, the fan motor amps. Oh, everything's running great. And then the compressor will die like a week later or 2 days later. And like, well, I just checked it. I don't know why it died. I guess it just happened. With this tool, it tells you what's happening inside the compressor with the windings. And you can find out if this is going to go bad before it goes bad. Imagine you're going to Mrs. Jones' house. Mrs. Jones, we've checked out your whole entire unit, and everything's running good except your compressor's over here in the caution. If you want to come outside, I'll show you how I find this. We show them what's happening. They get to see it's in the caution zone, or you can take a picture of it. They don't want to go out there with you. Take a picture of it, show them. Your compressor's getting weak. Now, it could run another year, or it could go bad. It could die tomorrow. It's saying that the insulation in the windings is starting to break down, and we're going to have a problem. Do you want to look at seeing what it would cost to replace that now, or do you just want to gamble and see if it'll make it through the summer? What would you like to do?
Probably replace it now.
Place it, or they'll ask, well, how much is a new one? Well, we have a comfort advisor. Now, another word for comfort advisor, you guys probably know him as a salesman, but a comfort advisor. They advise people in comfort and how much that comfort options are going to cost. So then you set the sales guy up, the comfort advisor up. Use the word comfort advisor, don't use sales. Sales is very abrasive, right? Nobody likes, hey, I want to send a comfort advisor. He's going to advise you on comfort. Comfort consultant is going to consult you on comfort. Okay, so we send them out. They're going to most likely make that sale. But here's the benefit to Mrs. Jones. Mrs. Jones can't handle the heat. Right now, the weather's not too bad. We're going to have her scheduled a time where we can come out and change this, what works best for her, so she can be gone that day or have other cooling capabilities, and so that she'll have running through the summer without a problem. Versus plan B, hey, everything looks great, and then summer comes in June, on a weekend, of course, and boom, her AC dies, the compressor goes dead. Call somebody else out. Oh, your compressor's dead. Man, we're booked up for like 2 weeks. I want to have 2 weeks without cooling? Are you kidding me? Everybody's booked up. She's going to be pretty upset. Now, if you gave Mr. and Mrs. Jones those options early on and let them decide what's best for them, hey, if they choose to gamble, then it's 2 weeks, 3 weeks out. Man, we should have replaced that. We had a chance. Versus, you just checked this. What do you mean I can't have air conditioning for this? You were just here and said everything was good. This tool is a tool that saves you. Megometer, a megger. Okay?
How much is the tool?
Oh, I don't know prices, but I don't know. Probably like anywhere from 80, 130, something like that. Yep, makes you money. Makes you money. Every single unit I work on, I check with this. And here's what's cool. Now, this is a megometer. Ohms is in there. So if I'm going to use it, it must be off and isolated, right? So what we can do is we shut that disconnect off, check line 1, line 2, line 1 to ground, line 2 to ground, make sure there's no power. And really, I can just put it on the top of the contactor. Put one on the top of the contactor, one on earth ground, press the button, check it, do the same thing from line 1, line 2, and it checks like everything. It checks the condenser fan motor, checks everything. Now, if one of them shows caution, I'm going to then isolate that individual component and check it. But it's easy to do. We're going to do it in lab here in just a little bit, but I'll pass it around. Any questions yet? No? All right, so in lab, we're going to go back to lab. We're going to mega unit. We're going to hook up the start kit. We're going to check startup amps without a start kit and with the start kit. One more thing. The time delay. When I said that these digital units have the time delay, most digital units have a time delay, which means if it was shut off and turned right back on, it's going to have to wait 5 minutes. It doesn't know if it was on or off before it was shut off, so it almost always waits 5 minutes. So if a unit, when you're checking a unit, if it's running, you want to check everything you can while it's already running. If the unit is off, you want to check everything you can with it off before you start it up. Because every time you're wanting to check something, you're having to turn it on and off, you're having to wait 5 minutes every time before it comes back on again. At first, 5 minutes doesn't sound like a lot of time. But some of you guys have been there waiting for it. Like, it's been more than 5 minutes. I know it has. And I know it hasn't, because 5 minutes seems like forever when you're waiting on it. So that 5 minutes can seem like a fortune. I actually had a couple of guys that worked for me that they called me and said, oh, they're having problems with this, problems with that. As they went through the steps of diagnosing, like, what's the time delay in the thermostat? It's got to be. And they're like, no, but we waited 5 minutes. I said, no, set it for cooling. Do not touch the unit. Do not touch anything. Call me first, and then I'll tell you what to do next. But don't touch anything. Okay. So they called me. Hey, this thing's still not on. Looked at my phone. It had been 4.5 minutes. 4.5 minutes ago. I said, you need to wait. Wait 1 more minute, and then call me back. They call me back. Oh, it's running. It's time delay. But they wasted over an hour of time, of my time that I'm paying them for, of messing with it. So every time they do it, it wasn't coming on. So they would shut it off, and they go check something else. Well, that's fine. Then they turn it back on. Maybe it's going to work now. Nope, still not working. Before the 5 minutes got there, they shut it off to go check something else. They kept shutting it off over and over and over. That 5 minutes reset, and it was another 5 minutes until like an hour or 2 hours went by, and I was very upset. I was not very happy. So 5 minutes can seem like forever. All right, so let's go to lab.